So we were on WAP, and WAP, if you remember, is this system which allows wireless access to web pages. So normal web servers could be designed for WAP accessible, or they would not be designed. If they are not designed, then there is a filter required which somehow changes the big page into a small page. And so that is one. And then the proxy is here, because proxy further reduces these pages, which are, even though they are designed for wireless devices, to compress them, making them binary, and so more like a zip, and that way less number of bits are transmitted over the air. So the WAP proxy's job is to convert from ASCII with the WML. WML is the wireless that WAP markup language, and so that converts WML to binary WML, and this filter's job is to convert a normal web page to WML. Okay? And nowadays most sites actually are basically designed for the WAP, in the sense that when you go to m dot something, so let's say Amazon.com is one page, right? But you go to m.amazon.com, that will be a site which will be suitable for just little screen, right? So that's the kind of notation that is developing. It's not a standard, but generally m dot something is for mobile. And you might want to try out m dot eBay, m dot Walmart, m dot whatever. All right. So that's the WAP infrastructure. So the markup language, basically an XML based. So in any XML based language, you have to have a URL which tells where to get the information about that language. So this WML is described at this place, wapforum.org WML 1.1.xml. So when this page goes to any XML capable reader, which is what most of the browsers are, they will go here, and they probably have a cache of this anyway. They will use those definitions, and so that creates new definitions such as card ID, P mode, and other things. And now the card, as you said, is that the web pages look like cards, a deck of cards, one behind the other, and so each of these is a card. So this is the beginning of a card, end of a card, and this is the beginning of the card. Card and card, right? So and then you can flip back and forth between the cards, which is similar to tabs, or you can think about Windows even. But while on the computers, we don't really keep Windows one behind the other, but when you do it on your mobile, even you use Firefox or anything like that, generally you see those cards when they show you pages, 5, 7, 8 pages or something like that, they show you. So that's the whole idea of the cards. All right, so describes contents, formats, and data display on the devices with limited bandwidth, screen size, and user input capability. So that is what WML is for. And so it can describe text and images, layout, just like HTML does, but it has a card metaphor, and then somehow there is a translation of that card to your device, but every device is different. Just like every display is different, every laptop is different, so that's not news. Basically, HTML is written so that you can render it on any display. Similarly, WML is written so that you can render it on any little display. That's all there is. So that's WML. And again, more points here in the references here. All right. Talking about security, WAP has quite a bit of framework here, but the key thing to notice is here, this column. So it has cryptographic libraries, authentication, identity, PKI, transport security, which is like SSL, and secure bearer. Bearer is the wireless part, the even below data link. All right, and rest of it is the normal application. So there is nothing, I mean, special here, but these are the things that are part of the WAP, and so it supplies all the security that is required for authentication and for encryption and for actually let's see, so authentication, user authentication. I'm just thinking whether there is a message authentication here anywhere. PKI, secure transport. So maybe part of the secure transport there might be message authentication. So this is user authentication, and then the secure transport, just like TLS, has both message authentication and message encryption. So all the libraries are supported. Authentication, TLS is supported. So there is a new word here, WTLS. TLS we know is SSL, or transport level security, and then WTLS is wireless version of that. And this is client authentication as opposed to message authentication. Identity is the WAP identity module stores user IDs and secrets. So that is user ID and user authentication. PKI everybody remembers is certificates. Secure transport is WTLS over datagrams. So there was basically there are two other versions of TLS that we didn't talk about in this course. One is called DTLS. So the TLS works over TCP. DTLS is datagram TLS, and datagram means no connection. TCP requires a connection, so you have a kind of a session or something, and then you get a key, and with that key you use it for the whole session. With datagrams there are no sessions, so you have to have per packet key.
So is it done over UDP then?
Yeah, this is over UDP. Yeah, datagram means UDP, and so DTLS is designed so that you can encrypt UDP packets. And there is one per packet key, and then how that packet key gets transformed or calculated at the other end, that I don't have the details here right now, but if you are interested you could find out DTLS. And similarly WTLS is basically another transformation of DTLS for wireless, so that the number of bits are reduced. Alright, secure bearer is basically what is underneath the transport. In this case it could be IP or IPsec. Service discovery. So this is service discovery is should be here somewhere. Navigation discovery, service lookup. So service discovery is external functionality interface allows the application to discover what services are available on the device, okay, and provisioning to set up the parameters, find the new network services, and to service lookup is the services parameter using DNS. So basically the idea is that the BAP protocol also has some commands which are common to all the devices. So you can ask the device, what is the size of your screen? Alright, and you can ask what protocols, and there are other things like what protocols you support and so on and so forth. So that is what is called service discovery, is that basically both ways things could be negotiated as to what your size is and what security parameters you need, and all of those things. So that is what is under service discovery. Alright, so then there is a WAP application environment, which is like a library of modules that can be used. So for everything that we have, like for example for their app, they use the library. So there are libraries for BAP. If you're writing a BAP application, then you can use those libraries. So they are like any other library. Basically, they have all the things that you need. So user agents, software modules for devices and displays, wireless telephony applications for telephony, and content encoding for web content, push to push the content, to send the messages over the air, and SMS, etc., etc. So for all of the functions that you might do on a mobile device, there is a library. Now, in terms of protocol architecture, the device has these layers: WSP, WTP, WTLS, and WDP. WSP is session, TP is transport, TLS is, as you would expect, the security, and DP is the datagram protocol. Alright, so these are the 4 layers here, which are also in the gateway, BAP gateway, and the BAP server may not have any of this BAP stuff, so therefore the BAP server speaks the standard HTTP, TLS, TCP, and IP. So the gateway receives the standard stuff and translates it into the BAP stuff. And you can see the correspondence, and the strange is that basically bearer corresponds to IP, the TCP corresponds to WDP, which is the datagram protocol. TLS is this layer, and then HTTP, the application has both session and the transactions. So basically, the normal transport has been divided into 2 parts. One which so TCP actually is session layer as well. TCP has a session layer, that's why it has a connection. And but here that is part of this SP and TP here. Okay. So key thing to remember is that the WTP transaction protocol is not complete transport. It has some functionality of the transport, actually mostly for transactions. And basically it divides the transaction into 3 classes, class 0, 1, and 2, and with different levels of reliability. And so that's what this WTP does. It's not a transport protocol. The real transport protocol is WDP. WTLS, wireless transport layer security, it is based upon TLS, and the main difference is that the bits are very expensive and therefore everything is compressed. The certificate format is compressed, the data structures are compressed, and rather than TCP stream, they use packets. So each packet has its own key and so on and so forth, and the gateways does the TLS to WTLS translation. Now there are 2 situations where the wireless may or may not be IP. So this is the situation here, is that the bearer here may be IP or may not be IP. In the old days it was not IP at all. In the old days IP was not used in the cell phone networks. IP was only used in the wired networks. Today there is a move to make bearer IP. So the telephone companies are adopting, and maybe in 4th generation it will be all IP, but in 2nd generation and 3rd generation this is not fully IP. So that's why in particular you need WTLS, because WTLS does not require IP, whereas TLS requires TCP and TCP requires IP. You cannot run TCP without IP, and you cannot run TLS without TCP. So this is designed so that it can run on anything including UDP, but it can run on any other protocol which is nothing to do with the TCP IP protocol. Now BAP version 2. BAP version 2 is IP end-to-end and therefore TLS end-to-end. in web version 2 you don't need WTLS. There might be a picture here for web version 2. Yeah. So yeah, this is web version 2, web 2. I will go back to the previous slide, but in a minute. But basically, when there is IP end-to-end, then you don't need WTLS. Then you can just do straightforward HTTP, TLS, TCP, IP, even in the device. And then the gateway is trivial. Gateway is like a normal, basically, is normal. It just forwards the encrypted messages. It doesn't even have to decrypt. In the case of web 1, all the messages have to be decrypted and re-encrypted from TLS to WTLS. In fact, it doesn't even have to do TCP. It could just do IP. The gateway could just do IP, and then just like a normal router, which doesn't read TCP at all. All right, going back to this picture here. So everybody understands what is the need for WTLS. Two reasons. One is that the cell phone networks did not have IP. And since they did not have IP, they did not have TCP, and therefore they could not use TLS security. Second reason is just the bandwidth, throughput. The normal certificates are just too big for wireless. Okay, those are the two reasons. All right, now WTLS, just like TLS, if you remember, TLS had 4 protocols. So WTLS has 4 protocols: handshake, ciphertext, alert, and the record. Anybody remembers what is the function of the record protocol in TLS? Yeah.
It does the actual encryption.
Yeah, so that's the encryption protocol. This is the negotiation protocol, and this is the error messages, alerts, error messages, and this is nothing. This basically is change cipher spec is whatever you have negotiated, let's use that. Right, so those are the 4 components. Exactly same here. And notice that the WTLS runs on UDP IP or WDP, which is actually cell phone version of bearer. Okay. Now in terms of facilities, it uses RSA, ECC, and everything else is very similar to TLS and standard. MD5, SHA-1, DES, 3DES, RC5, everything else is standard. So we already saw this slide, both sides. This is when IP is end-to-end, then we have a choice of going to the transport layer or not going to the transport layer at all, and just acting like a normal router. And depends upon the content though. I mean, if the content has to be filtered or something like that, then maybe you will go through this way, get the content and change it over for the other side. All right, so BAP end-to-end security over BAP 2 end-to-end security over IP continued. So here is another thing is that basically the way it works is, BAP works is that you call your tower and that connects you to a BAP gateway, and you get all your content through the BAP gateway. All right. However, some companies may not trust the telephone company's BAP gateway. They don't want them to be decrypting their information or encrypting their information, particularly the hospitals and banks. All right. So they will have their own BAP gateway. When they have their own gateway, basically you connect from here, but then they redirect you through that message that please connect through here. All right. Once you connect through that, then you really get end-to-end security, which is not hampered by any cell phone stuff. So I mean, somebody can take responsibility if something gets broken. Then we know who to blame to, rather than cell phone companies knowing all the secrets and then somebody stealing it there. So there is no decryption. All right, so you understand the need for this picture. There are some situations where we don't want to use phone company's BAP gateway. In that case, we will use our own BAP gateway and tell the device to contact to our BAP gateway. So basically, one thing which is not shown here is the tower So in between here there is a tower. And so this BAP gateway sends the message to the tower and then goes to the phone system. Here this sends to the tower and goes to the phone system. So right now it is showing directly to the device, which really means going to the tower because there is no direct wire to the device. There is a tower there. Alright, so that brings us to the end of this wireless security. And then we talked about three different things actually, or maybe two different things. I thought there were three different things. So what was the second thing? BAP. Okay. So two different things. So basically, in Wi-Fi we had two different standards. The BAP standard. First of all, what we did was we just defined what a Wi-Fi looks like. So a Wi-Fi LAN consists of BSAs and ESAs, extended service areas and basic service areas. And basically the difference between the two is that the many different BSAs will be connected by wired backbone, and that is called the distribution system. So you should know what is a BSA, what is a distribution system, what is an ESA. Then we went into security. The first standard was called BEP, which is wired equivalent privacy. And it used RC4 for encryption and CRC32 for MAC. And both of them were basically weak. And therefore they were trivial to break. So the new standard came out, which is called WPA2 or RSN. However, that requires hardware change, so therefore one more method was invented, which is WPA or TKIP. And so the TKIP provides 64-bit MAC rather than 32-bit CRC using, and then it uses the same RC4 though with 128-bit key. But the packet is per packet key. So that's the thing, that's the difference. Is this per packet key where this is a shared key. In the case of WPA2 is hardware, and therefore we can use AES encryption, and that can be used for both authentication and encryption. Then we talked about cell phone world. In the cell phone world we use BAP, and so the BAP had many layers like sessions, transactions, datagrams, and so on and so forth, those protocol layers. And then we talked about the WTLS, which is the wireless version of TLS. All right, any questions about any of this stuff? Everybody was busy writing papers, so they haven't really read or slept last night. Any questions? None? All right, let's see the homework. Web assumed all devices in the network share a secret key. The purpose of the authentication scenario is for the STA to prove that it possesses the secret key. So as long as you have secret key, you are authenticated. As shown in the figure below, the STA sends a message to AP requesting the authentication. The AP issues a challenge. The ST issues a response, and the access, and then it says fine, you are successful. Now, first of all, there are three questions. This authentication is one-sided. So who is being authenticated here? And that you have to tell, yeah, there is only one side is being authenticated, and how can it be made mutual means you need to add some more messages afterwards to make it two-sided. Second is, what information does it provide to attacker, making it easy to attack? Now remember, this is RC4, and here, I think there was a question in the exam also as to how RC4 can be easily broken if you know the both plain text and the ciphertext. So that's the thing, is that it is very easy to attack. Anybody can basically, without knowing the key, they can pass. Discussion RC4, how can attacker create a valid response challenge after just valid authentication? So you don't need to know the key, you can just get the valid response. So just basically knowing about the RC4. Any question about the homework?
When is this due? When is the reviews due?
Everything is due on Monday.
Everything's on Monday.
Now the reason is because you don't have too many days left. The exam is on December 5th, and there is no class that Monday. So this is the, I think, let's see how many Mondays we have left. We have only probably, today is, so last Monday was 14th, 21 and 28. So we have 2 Mondays left, 21 and 28. And so I really wanted to finish everything off on 21 and not really have it over the long break. I mean your home break or whatever it is. So I wanted to finish everything on 21st. And so I know you guys are going out of town for the weekend, so you can mail it on Monday or Sunday or whatever it is you want to mail it in.
Will there be homework next Monday?
Will there be homework next Monday? Technically, yes. The thing is, there is a class on Wednesday, isn't it? There is Wednesday holiday?
Yeah.
Okay. So there is a class on Monday, and every lecture comes with the homework. Now what I could do is, the only maximum I can do is I can make the homework due on Wednesday maybe. Because you have to do the homework. If you don't do the homework, you won't read it and you won't be doing well in the exam. And so maybe next Monday I will give the homework, but make it due so that you get some time to do it after you come back from home. Okay, that's a good question. All right, we announced right on the first class. How many people remember that we announced that the final exam will be on the last day of the class? Anybody remembers that? Okay, so most of the people remember. That is the date and this is the room. Ignore any messages coming from anywhere else which give you any other date or any other room. 5th, 7th, okay, December 7th. It's on a Wednesday and there is no class on the Monday. Okay, December 7th. So it's on a Wednesday. So exam is on December 7th. Yeah, that's correct. You're right. Yeah, question. Okay, hold on. Before that, yeah, George.
When's the website due?
Okay. So 21st you get the reviews back. All right. Yeah, that's a good question. So 28th the HTML is due. Now that is basically over the long break, right? Maybe I can make it 30th or whatever. I mean, if it is really important, because most of us work during the break anyway. But if not, we'll just give you extra days. All right? Yeah. Go ahead. Now, is that so? Okay. So, but the reviews are due on Monday. Reviews cannot be delayed beyond Monday, right? And you can. If you're not coming in here, please email the reviews so we can email it back to the people who need the reviews. You will get your own reviews by email. Well, I don't know how to email. That's another problem, because the reviews are coming back in paper. Right? And the papers are coming back as well. So there we go. Somebody has to pick up somebody's reviews. I mean, maybe, so you guys, who is going out of town in the long week? 2 people. 5 people.
Next weekend?
Long weekend, yeah. I mean, like Thanksgiving.
So you're going to come on Monday?
See, think who would be absent on Monday? 2 people will be absent on Monday. Well, you have to make arrangement with your friend to pick up your reviews and drop your reviews so that we can give in hard copy to everybody. Yeah.
So I saw there's a presentation on the December
5th, yeah, I cancelled that. This was today. It was demo presentation.
So for survey there's no.
No, for survey there is no presentation. All right, let's see. Yeah, we are almost at the end of the class.